I think now is a good time to give a little refresher on how to use exponent properties. This is definitely an old topic for an Algebra 2 student, but it's been a while. It's probably been a couple years for you. So there are some properties that we have to remember, and a lot of our problems are going to be algebraic, so the fact that, yes, technically we could type some of these in our calculator is not going to help you. You still have to know the exponent properties. So the first one says if you're trying to multiply the bases together, and they happen to be the same base, with exponents, what you do is you're going to keep your base, and then you're going to add those exponents together. So in this example, we're going to keep our base of 2, but then we're going to add those exponents together and get 2 to the 11th power. And I have no idea what that is, something very large, so I'm just going to leave it like that. The next property says if you have a base raised to a power, and then all of that's being raised to another power, the way you combine those exponents is you multiply them together. So in our case, with this next example, keep the base of 2, but now you're going to multiply your exponents together, get a 30. It's coming back to you now, right? All right, so our next couple properties, let's take a look. This one is saying that you have a multiplication problem of different terms inside here, but all of that's being raised to a power. Well, this is the one time that you're, well, one of two times that you're allowed to whoops, I got crazy with the arrow. You're allowed to distribute your exponent to both of the bases. So same thing's going to happen here. We have 3 and x, which are separate bases, and we're going to distribute them to their exponents. So this becomes 3 to the 3rd power and x to the 3rd power. Now you could take this further and call that 3 to the 3rd power 27, x to the 3rd power. But the point of our lesson today is to illustrate the properties of exponents. So as long as you've done that, I'm happy. All right, this next one is one of my favorites. The negative exponent property says that that base is on the wrong side of the fraction bar. So every number I write down has a fraction bar, whether you realize it or not. So in this case, the a is the base, and since he had a negative exponent, that meant we needed to take that whole term and move it to the other side of the fraction bar, and thus it would become positive. So like on this question, there is a fraction bar right here, and I noticed that 5 has a negative exponent. So moving that whole term down to the denominator, now it's 5 to the 1st power, and you have to have something in your numerator, so we'll leave 1 as a placeholder. So 1/5 is a good answer for that question. But it works for both sides of the fraction bar. So in this case, the 6 has a negative exponent, which means he's on the wrong side of the fraction bar, so moving him back up to the numerator now. And now it has a positive exponent. And if you want, you could leave 1 as a denominator, but no one really does that, so let's just call that 6. This is probably the best exponent property out there. Anything to the 0 power is equal to 1. So literally anything. I saw some really creative ACT questions back in the day. So 9 to the 0 power is 1. And if you're not sure, you can try typing anything to the 0 power on your calculator. It's going to give you 1. This next property says that if you have the same base and you're trying to divide them, but they happen to have exponents, you could combine it by subtracting your exponents in that order. It has to be numerator's exponent minus denominator's exponent. So like on this question, same base, so keep the base of 2, and then subtracting 8 minus 5 would be 2 to the 3rd power. Now, be careful here. Same base, so keep the 3. 4 minus 7 in that order is -3. So now you're going to have to go back and use that negative exponent property that says, yeah, it's really on the wrong side. So 3 to the 3rd power is now in the denominator with 1 up top as a placeholder in the numerator. And this is the other time you get to distribute. When you have a division problem, just like here with the multiplication problem, this m power is going to be distributed to both terms. So our example here, 2 to the 4th power over 3 to the 4th power is another way to say that. Now it'd be nice if I just gave you problems that had one property, right? You could illustrate those all day long, but we're Algebra 2, and this is like the second time we've seen this, so I think we can handle problems that have multiple properties within them. The bad news is you and your neighbor might attack a problem totally differently, but you're still going to get the same answers. There's not really like a best way to approach a problem. Sometimes there is a more efficient way, but who cares? Saved yourself 1.3 seconds. Excellent. All right, so when I look at this first question, I see a couple of properties, and don't freak out because it does not matter what order you do them in. So first thing most kids like to take care of is the fact that there's parentheses. This 2 is going to be distributed to both of the terms, the numerator and the denominator. So it becomes r to the second power. And there already is an exponent here, so we're also going to use that power property that says you multiply them together down here. So negative 5 times 2 is going to become s to the negative 10. Now, you can't subtract these exponents because they don't have the same base, but I do notice this negative 10 indicates that this base term is on the wrong side. So the r squared can stay where it's at, but now that s to the 10th power is going to join them up in the numerator. There's nothing left in the denominator, so you can say over 1 if you'd like, or you could just say that's your answer. Or r. The idea is you're not done simplifying until all your bases, like bases, are collected. There can't be any negative exponents, and there shouldn't be any parentheses left in your problem. So let's take a look at this next example. I notice there's parentheses right away, so let's go ahead and distribute the second power to each of my terms. So this is 7 to the second power. Let's go ahead and write that as 49. And then b to the negative third to the second power, we're going to use that product property again where you multiply them together. Power to a power, I think it's called. So b to the negative 6. And then there already was b to the 5th, b to the, remember, first right here. So can we just collect those together and call it b to the 6th? Because we added these together. Well, look at this. If we add those together, that ends up being b to the 0. And isn't b to the 0 just a 1? So essentially we have 49 times 1. Boring, 49. All right, this next question. I'm going to distribute this third power to each base. There's quite a bit to collect here. So this is y to the first. I like to have exponents when I'm working with exponent rules. Z to the negative 2, x to the 6th, and this will be y to the third. And then don't forget there's a random z to the first back there. So let's collect anybody who is a like base. So I'm thinking this y and this y can be added together. And then this z and this z can be added together. Doesn't matter what order you write these down in, but generally they go in alphabetical order. So x to the 6th, no one collected with him. But then this is y to the 4th when I use that adding property. And then adding these exponents together, I get z to the negative 1. Still not done. Because remember, anything with a negative exponent means that that base is on the wrong side. So just the z is going to move. So x to the 6th and y to the 4th is going to stay. And then z to the 1st is now down in the denominator. I write my z's like that because otherwise my z's look like my 2's and everyone gets confused. That rhymed. Alright, so let's take the negative 4 and distribute it to, careful, each base. And there are 3 of them right here. So this becomes 3 to the negative 4, x to the negative 12, and y to the positive 8. Now there's a couple things we should take care of. First thing I notice is these guys need to move, but the y can stay. And then the other thing we might want to think about is 3 to the 4th power could be simplified if we wanted it to be simplified. So y to the 8th is up in the numerator still. 3 to the 4th is an 81 if you found that on your chart or on your calculator. And then now it's x to the positive 12th because we moved it. Remember all those? All right, a couple more. These are going to be very algebraic in nature, so hang on. We just got a couple slides and we're all good. All right, so here, parentheses. I don't like them. Let's take care of them. So we're going to distribute the squared power. This becomes x squared y to the 2nd up in the numerator. Haven't done anything to the denominator yet. So let's just write that down. So this is where some of us are going to kind of differ in our approach. For some people, they just follow the exponent rules, and that's how they do these problems every single time, and that's fine. Some people are more visual, and they think about what x squared over x to the 3rd means. X squared means this, and x to the 3rd means this. So like x, they would all cancel, leaving you with 1x in the denominator. That's how I do these problems, just because like I have really bad dyslexia. So when I subtract 2 minus 3, like in my brain, that's a 1, even though I know it's negative 1. So if you want to take a visual approach, that's fine, but I'll show you what it looks like when we're following the rules. So subtracting these exponents, it's x to the negative 1. And then careful here, 2 minus negative 1 is 3, so it's y to the 3rd. So at some point, you're going to end up moving this x to the negative 1st down to the denominator, and you end up with y to the 3rd over x. But like I said, some of us take a more visual approach and we're like, oh, there's one more x in the denominator, so that's what we're left with when we reduce. And then that visual person, who's me, by the way, would take this y to the negative first and would have moved it up to the numerator and collected it with the other y's. It doesn't matter. You just have to watch your signs. And like if you know that, like, you have a little dyslexia like I do, and you know where your mistakes happen, you just have to kind of combat that with some other method. So here, if we're being a rule follower, and we're going to just follow the subtraction rule here, 4 minus negative 3 is 7. And then here for the y's, 3 minus 0 is 3. And that's actually the final answer. So the rule follower had probably less work than I did, because when I did this question, I moved x to the negative 3 up top, and I thought of it like this in the numerator. And then I remembered y to the 0 is just a 1, so I just ignored it completely. And then my final step was, I was going to get the same answer, obviously, but it's just one of those things I've learned to deal with. All right, this next question I like, because sometimes we get so focused on exponent rules, we forget that coefficients are not exponents. So a lot of kids do 12 divided by 8, and they're like, oh, I'm supposed to subtract. No, you're supposed to divide. 12 divided by 8 is 3/2. They're both divisible by 4. So the x's, however, those have exponents. So you should be using your exponent rules. So x to the negative 5th over x to the 6th, we're supposed to subtract in that order. So we end up with x to the negative 11. Whenever you use those subtraction rules, everything defaults to the numerator until you move it later. And then for the y's, y to the 7th over y to the 4th is y to the 3rd. Now, can you tell we're not done? Because this x to the negative 11th is going to have to take a hike down to the denominator. So 3 stays, y to the 3rd stays. The 2 is still where it was, but now it's joined with an x to the positive 11th power. So again, if you want to do a combo approach where, like, I have a lot of kids who move the negative exponent terms right away because they don't like to work with negatives. So I get that. So that's one of the things that they've learned to combat, because they know they make mistakes with negatives, so they move the term to make it positive. All right, these questions are not ready for you to try to reduce. They're all over the place. So my suggestion to you is to view this numerator and denominator. They're multiplied together, so they're really one big fraction. Let's clean it up a little bit. So this numerator is really a 20, and then it doesn't matter for the order, but I'm going to go x and then y over 2, and then careful here, I have x with another x to the 8, so it's x to the 9th, y to the 6th. So remember, 20 divided by 2, those are coefficients. That is a 10. These, however, are exponents. So 14 minus 9 is x to the 5th. And then exponents again, 10 minus 6 is 4. Nobody's negative, no parentheses, everybody's collected. I think we're done. All right, I don't like the parentheses, so let's take care of this. We're going to distribute the negative 3, careful, to every single term. So it's 2 to the negative 3rd power, and I wrote over my problem. Okay, so now it's x to the negative 3rd power. And then down here in the denominator, this becomes y to the negative 6. This is an interesting piece of, like, literally every single term is on the wrong side. So y'all are going to have to move. So now it's y to the positive 6th power up in the numerator. Instead of writing 2 to the 3rd, I'm going to go ahead and write that as an 8, but if you wrote 2 to the 3rd, that's fine. And then now it's x to the positive 3rd power in the denominator with the 8. All right, I have a feeling the next slide is our practice. There is. So I'm going to be assigning these to you for homework more than likely, so I'm going to save all the glory for y'all. Some of them are numerical. I want you to try not to use your calculator, though, and just use the exponent properties. And then when you get to the variable ones, it'll be a piece of cake, right? We're going to have a follow-up lesson on this where we do rational exponents, which means same exponent rules, but all of the numbers that are exponents are going to be fractions. So, yay, something to look forward to.